Hello,
This is being recorded.
Hello, everybody. My name is Nikolai Gabrowski, and I will lead this webinar of the task force of the European Association of Neurosurgical Society with the complicated name Task Force for Emerging Technologies and Innovations in Neurosurgery. I'm very glad that today we have a very prominent guest. This is Professor Nabavi. Professor Nabavi will talk and will present us the topic about the cooperative robotics, technical advances, concepts, and ethical considerations. Before starting, I would like to present you Professor Nabavi very briefly. He is the director of the neurosurgical department of Norstadt Hospital, Hanover, which is a teaching hospital of the Medical University of Hanover. He holds his professorship within his alma mater at the Christian Albert University in Kiel. His interests in robotics and in the advancement in technological advancements in neurosurgery are dating that in more than 30 years. He had been for 2 years in the Harvard Center for Minimally Invasive Surgery for his work at the worldwide first installation of an intraoperative MRI, Signa SP, at the Brigham and Women's Hospital, Harvard Medical School. In the beginning of the century, he returned to Germany and had a PhD thesis on a computer assistant and MR-guided surgery. Also in 2001, he was one of the founders of the German Society for Computers and Robot-Assisted Surgery, for which he served as a president for 2015 till 2017. So, as all of us know, the topic about artificial intelligence, about robotics is extremely interesting and, of course, very, I would say, modern. But the reason for this topic to be modern is that we all see that these topics will change completely the way we work. We will change probably our whole society. So I think that there are very interesting questions that could be discussed, and this is why I will give Professor Nabavi the floor. But before doing this, I would like to tell you that we shall expect your questions during the presentation of Professor Nabavi. Please use the question and answer box that is at the bottom of your Zoom window, so we will be able to answer them at the end of our webinar. So, Professor Nabavi, please, the floor is yours.
Okay, can you all see the presentation?
Yes, we do.
But on the wrong monitor. This is, which one do you see? Do you see the one with the second slide, or do you see the ordinary one?
We see the second slide as well, yes.
Okay. That worked well when we practice it. Now again? No,
yeah,
now
it's okay.
No, that's good. Well, sorry, Nikolai, thank you very much for this kind of introduction. And I'm very happy and grateful to be part of this webinar and to be asked by the task force. And I think that's a very, very important task force for the European Association, particularly as you alluded to, the future belongs not just to AI and robots, but to common intelligence and human intelligence. And we are the ones, and particularly societies like the European Association and also the World Federation, are the societies that need to drive this effort and make sure that humanity does not end up like in the Terminator movies. So robotics always sounds like science fiction. I mean, there is a reason for this matrix background, and has some authority to attract attention. And what is cooperative robotics? A new way of selling an old head, basically. Maybe not. I'll try to convince you that it isn't. Before recurring to this, I will have to say what this talk will not and cannot provide. It cannot provide a comprehensive review with detailed specifics and in-depth analysis of present and future applications and systems that is way beyond what this short introduction can be. Also, please allow me, I'm working on 3 computers, so if I do not look at precisely the right angle to the camera, please forgive me. As Nikolai already said, I'm working at the Nordstadt hospitals, and I've been involved in this field for the last 25 years. Myriad changes have taken place. Certain issues, however, remain, particularly prejudices, preconceptions, and incorrect generalizations, which are impeding the constructive cooperation of engineers and neurosurgeons in designing systems that will benefit our patients. So before contemplating real cooperative robotics, we need to actually find some common ground that needs to be established within the neurosurgical community as well as within the communities of engineers and neurosurgeons. I think all of us anticipate a robotic future. However, I think we have a pretty hazy idea of what it actually will look like. Now, this would be perfect for us to be on vacation and have these C3PO units work. However, I think none of us wants to be without work or without food. So a lot of people look with apprehension on the future of robotics, and particularly surgeons have to look with some skepticism, because if at the end of the day, it is us that really has to talk to the patient's relatives and make sure that the patient is well. Also, we need to form a solid basis for the dialogue that I was referring to in between engineers and roboticist developers. For this, we need to understand the subject and define our own demands based on firm knowledge of what we actually want to achieve and how we want to contribute to the medical field. And that is very important, not just have another checkbox on the webpage that says we do robotics as well. And I'm sure a lot of you will know those web pages and will also be able to find those people. So we need to really concentrate on what we want to achieve. So in a short overview about what this talk is going to be about is first the question, what is a robot? Then I would like to go into the questions of, is there a robot, or are there multiple current systems, of course, with common denominators, common differences, but I would like to enlarge on the classification in regards to the man-machine interaction. I will not try, I would like to advance from there, and I would like to make sure that we all have the basis on knowing how to advance and where do we advance to. And then I'd like to skip into a couple of the caveats that future development might hold for us. I guess this is what most of us think about when we think about robots. And meanwhile, with the new versions, we also have smiling robots. However, robots are all around us at present. We have household appliances like the vacuum cleaner. We have industrial robots. We even have military robots, which unfortunately have been quite notorious over the last couple of years. But what most likely is what most people think about when they hear robots are in areas of household appliances, which I find particularly appealing when you look at this cooking robot, which basically autonomously cooks according to a cookbook. You don't have to argue with anybody that the salt is too much or not, because the robot already provides that. Then we have the care robots, which particularly in overaged societies like Japan, are very, very on the upcoming. I mean, of course, even in our societies, we would like to have somebody grab coffee for us. However, these humanoids are very, very helpful in care for the elderly. And as you see, this almost looks like a cute little puppy. However, what for industrial nations is imminent is these heavy-duty working robots that have exoskeletons, and I'm sure that a lot of you already think about military usages, which hopefully will never happen. However, everything that is thought is thinkable is done by humans, and you see that the gait and keeping the balance appears to be very good in this video, but according to the people who did this video, when you ask them, this is one of more than 100 tries, and they stopped trying after this successful situation. So this is real, but it's not routine. We will still have to work on that. And basically having all these forms of robots makes it very difficult to define what we are actually looking at when we're looking at clinical robotics, surgical robots, or medical appliances. It is very important to bear in mind that at the end of the day, a robot is nothing else than a mechanical device with tendon-driven moving parts with a lot of degrees of freedom, which is controlled by a software or computer. So if you read about a robot, this is the common denominator, and all papers need to specify what they are actually talking about within, in order to make sure that you can actually follow the results. And robotics is nothing else than a multidisciplinary, by necessity, multidisciplinary science, which involves all kinds of engineers, material scientists, and philosophy, which we will go into at the end. But mostly for our perspectives, medical personnel and surgeons that have to define where the direction is going. Just to illustrate the confusion that we have in the literature is, if you look at two prominent publications. One is in Surgical Neurology International. It's a review article about robotics in neurosurgery. Now, after what I have said, I hope you would say, okay, what kind of robots? What are they used for? Blah, 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 and so forth. They don't allude to any of that. They talk about 100 educational programs in the United States and say that 30 of those offer robotics for cranial surgery, 40 offer robotics for spinal surgery. They do not specify whether they are the same services or what the robots actually do, what they're used for, and what kind of robots they are. So we already have a confusion in the labeling. And another problem is the application of the bandwidth. As you've seen in the examples of the robots that I showed you, there is a lot of appliances where they can be used. And so robotics in neurosurgery is a tremendous field. However, most of those articles that were neurosurgical focused, 15 of those 15 articles plus 3 editorials, so the topic is highly opinionated, 8 of those were spinal applications. And I will not go into the one really collaborative, everything else was just entry target positioning of screws. There was one Da Vinci review, which is, let's go into Da Vinci afterwards, and basically 6 stereotactic applications on the brain. So there is nothing where you would actually say, okay, this is something where I can use, where I need to use something that is computer controlled. A lot of these things can be done by stereotactic devices or any other kind of holding devices. The first examples of robot in neurosurgery was with the Puma 200 in 1984. And don't worry, I won't go year by year. But what you see here is a robot which is affixed to a table which is in the immediate vicinity of an imaging device. And remarkably, this is what still is on the market. You have a robot that is a pointing device in the immediate vicinity of a CT scanner or within this Burr-hole-mounted device, which actually was. There are Burr-hole-mounted devices way back in the 1940s. So we're going back with new innovations. That is also something that needs to be addressed by task forces. However, this Monteris device allows you to work within an MRI, so within confined spaces. I'll allude to that later on. And then there's a multitude of systems that are used in spine surgery. Oops, wrong computer. Then obviously what most people refer to as robotics is a telemanipulation device, which is the Da Vinci system. Now, this is the most highly marketed system worldwide, and it definitely has advantages in the areas of urology, gynecology, and general surgery. For various reasons, there is space enough for this device to actually be placed within the body and without the body. Now, everybody who does neurosurgery, and most of our colleagues here do that, there might be some engineers also, hopefully, know that space is the limiting aspect in neurosurgery, and so we will not have something like this on top of the head. So obviously the accessibility in neurosurgery is not really given with the Da Vinci system. However, what needs to be borne in mind, and that is a good part about the system, is as a telemanipulator, this person is not running the computers. These people back here are running the computers. Now, this might not be very comfortable. However, a friend of mine of gynecology who's doing that at the Brighams actually said, okay, while I could do 5 surgeries before we had the Da Vinci, now I can do 4, but my back is not hurting as much anymore because the ergonomics of sitting in the seat is much, much better. And this can also be something where robots can help us. It's to save the resource of the surgeon. Now, we have all of us neurosurgeons basically, we exploit ourselves to a much higher level than is good for our bodies. And maybe with computers and maybe with robots, we can have some more ergonomics and basically do surgery for much, much longer than at present possible. However, what is really interesting is the miniaturization of robots and the application within a certain setting. And these are all courtesy of Garnet Sutherland, who's in Calgary. And the interesting portion here is just to describe a master-slave system. The master is basically, of course, us. And we use an input device that allows us to steer a robot. I'm jumping over to the other side, to steer a robot in the immediate vicinity as a surgical robot. Now, there are some constraints, such as corridors and neuronavigational aspects, as well as depiction of the instruments in 3D, which allow us to run this robot on a monitor. Nevertheless, it is nothing else than the telemanipulation device of a Da Vinci, because it translates every motion that Garnet has. It's basically at present the only system that I know of. Every motion that he gives as an input through this device is immediately translated to one of those robotic devices in the operating room. We'll see a couple of more images of that. The basic idea, and you saw all those systems that are basically trajectory-based approaches to specific targets, cannot be defined by what they actually do. However, Young et al. Have put forward a very interesting definition in regards to what robots do as in the man-machine interaction. And it goes from no autonomy, robot assistance, task autonomy, conditional autonomy, high autonomy, and full automation of the robot. Now, obviously, this is too much to actually read through, but what basically the first and second level 0 and level 1 have almost no autonomy and robot assistance. Those are basically the systems that I already showed you. The system that Garnet Sutherland employs goes basically already into part 2, which is task autonomy. whether we would actually like to have autonomous robots that actually do everything by themselves, let's put that for the discussion. I personally would not like to have that. However, I could imagine myself appreciating a robot that drills away the temporal bone for me to do the interesting portions, and where I need my fine motor skills after the heavy duty work is being done. So this basically, I can only recommend to look at this. It's a very, very short paper by Young et al. And it allows us to actually classify robots in regards to their interaction with men and to our interaction with the robot. Robots have another advantage. They do not need much space, and they can stay in an area for a prolonged period of time without actually their back hurting. This is again courtesy of Garnett, who is working in, this is almost as close as it gets to collaborative or cooperative robotics, because he's working on a brain tumor, and this robotic device, which is basically a sidestep of the robo arm of the ISS, which was produced by Canadians, and this is in Canada, in order to have 4 hands within his surgical area. He definitely does surgery. He's not always sitting here in his chair, but this is another. This is the example of how using the input devices in a remote position drives the robot, which is here within the operating room. Here within the operating room, assisted by a second surgeon who is actually working here. So we have 4 instruments that are working in a small confined space, and all of us know how difficult that would be if we had another human and not a robot work in that specific area. Robotics, this is an interim summary here, not yet released there. There's going to be a couple of more slides. What I wanted to show you so far is that we have a large and inhomogeneous field. And for clarity in regards to the definition of surgical robots, we should define them as was proposed by Young by the man-machine interaction. The current systems are either trajectory-based systems or a master-slave system where the robot or the mechatronic device fulfills your orders. The transfer of results from other surgical specialties needs to be done with a large grain of salt, because we do have other tissue characteristics. The feedback that we have is different. And of course, the major issue is the accessibility. There is current research in nonlinear trajectories, so basically a needle that goes around the bend. I'm skeptical whether that will actually reach prime time. However, it gives us interesting input about material properties. And so how do we get on from here? As I said, these are the ones that are already being done. These are the ones that we should work on. And I'm pretty sure I don't want an autonomous robot. I wouldn't want an autonomous robot working on my brain. However, I think conditional autonomy, where a specific task can be ascribed to a robot, should be something that is available. And I'm thinking that it is within grasp. It is not within the near future, but at least within grasp, which necessitates some kind of robot autonomy, and it's called embedded neuromorphic intelligence. I find that very scary because it basically refers to having a robot that does the same thing as a human being with feelings, emotions, and everything, which would be good. However, we know that not every human being is good, and we do not know how if every robot would be good. What I call adaptive creativity basically refers to situational awareness to decide in novel and dynamic situations, which basically is what we do during surgery. Not every surgery is the same, which means that we need to comprehend situations and an environment, and a robot, in order to obtain autonomy, would have to have the same intraoperative control, be it by navigation, be it by electrophysiology, intraoperative imaging, and of course experience. So the robot needs to remember what has been done before, which is what we do during surgery. Also, what I refer to as anticipate iterative outcomes means what if I do this, what will happen next? What will happen next? So generalizations and predictions need to be included into the autonomy as well. And obviously the results need to be maximized. However, we need to define with the robot, and this goes into the consequences and the ethical framework, how do we actually define results in a way that a robot can perform them. For intraoperative imaging, and I'm not going to allude into that too much, there were various areas where robots were included. This is the double donut when Nikolai said that I was working, and you see that the robot is basically installed above the double donut. And with further miniaturization, it will be possible to have robots that actually work within an intraoperative imaging device. Is that necessary? Well, if you look at what actually happens during a surgery, as we all know, brain moves, so shift happens, but this is actually the depiction. And if you tell a robot to take out everything that is surrounded by this greenish line, what will happen after some resection of the tumor, as you see in the sensory glioma, see that the caudate nucleus is basically bulging further into the resection cavity, and a robot would keep on going until all of this tissue is out, which obviously is not what we want to have. So we need some update, and this would be an update to control that and to stop the robot from doing that. We did simulations in the old days, and even nowadays, the simulations that use finite element modeling do not predict brain shift in a way that actually can be used within robotic devices. What may help us, though, is further research into haptic devices, as here also displayed by the group from Garnet Sutherland, where we do not only move the instruments by telemanipulation, but we can also capture the forces that are actually exhibited on these instruments, which will help us to, in the other way around, make sure that these instruments can be used with a normal haptic feedback. So cooperative surgical robotics need to integrate the information as we do in our situational awareness, and need to include what we have as manipulation skills, creativity, and hunch or intuition. The robotic skills obviously are menial mechanical tasks. They do not tire. They can reproduce with precision for forever what they're doing. And they have multiple degrees of freedom, which allows them to work in confined spaces or hostile spaces, be it for rescue situations. How do we go on from there, and how do we empower the robots to actually have autonomy, as we refer to? Now, obviously, if the robot always needs to go back to the central processing unit that tells them, in coordination with all the information that has been gathered during surgery, how to react. First, the surgeries will take forever, and second, most likely, what we do with reflexes will come too late because the thought process will be too long. So as we do with ourselves, that we have reflexes or local autonomy within our hands, so that we do things that are correct without thinking, we need to empower those robots to also have these capabilities. And as they have the joints, and we have electronics to actually feel where the joints are, we can simulate those kind of reflexes, and we can take this information from the research for prosthetics and sensitive robots. So we're leaving the area of surgical robots and pick our suites from the area of prosthetics and research into how human locomotion works and how we can translate it to a robot. Now, obviously, most of us think of a robot, and this is the first issue that needs to be covered. The robot receives a task and fulfills it without mercy. Now, obviously, that is nothing that we can use in surgery. So Professor Sami Haddadin, who's a good friend of mine, basically was working on how to have the robots receive some sensitivity and to react to their surroundings. So the first issue is to do no harm. And he is smiling, and since this is a couple of years later, he didn't get too much harm by this very placative demonstration of robots that can stop in time. Also, they need to be able to react to certain stimuli without totally losing control. Now, this is simulating light pain by basically having a receptor here. This can also be a thermal detector that basically reacts to heat. You see that it shrinks away in regards to the touch, but still keeps the position. Also, the same as we with our joints, we need to know where we are and how to reposition ourselves. So proprioception can also be simulated by the joints and by a quote unquote sensitive robot. And the result is basically, as you see in this is a non-invasive ENG controlled robotic arm. And I'd like you to notice how the fingers actually move. In addition, it's when they grab the bottle. So this initiates the robot. Bottle is being grabbed soon, hopefully. And now watch for the fingertips. See how they readjust at the end. So this is something that is local autonomy in order to grab the bottle. Now, what also will happen is after the robotic arm grabs the cup, which also, please note, the fingertips, is going to be a collision detection. It's a bit lengthy. I thought about speeding it up, but then it looks very fake if you speed this up too much. This is the normal speed. And again, watch how the fingers tighten the grip in addition without another signal. And now an obstacle is placed in the way, which could be another surgeon at that position if you have a surgical robot. And it will stop and shrink away very, very strongly. Now, this is something that you can obviously do with computer programs to make it not shrink away that fast. But the basic idea was for you to see how this arm can be moved by this researcher, as well as how you have some local autonomy in regards to gripping the cup. So again, another intermediate summary. What we can do already is acquire intraoperative information. However, what we need to do and what we need to do more perfectly is to transfer the local control more into the robot and away from central processing units. We need, as surgeons, we need to define what we want. And as I already alluded to, full autonomy is something that at present still scares me. All of you and a lot of the people listening to us are residents, but all of you train residents, and we usually train them step by step, and we don't give them full autonomy in the immediate setting. And those are human beings that are being trained much easier than robots. So I'm very quizzical about full autonomy. The research framework of the future, how should that look? Well, there's a myriad of ways. Again, what we have at the Northshire Hospital is a cooperation with Professor Haddadin, where we actually have these kind of robots within spaces within the hospital. So we have our people, have the nurses, have have surgeons and have engineers together in a specific area to talk about issues and to try and solve not just problems, but to address problems and to find a common language. And one of the issues that I experienced is that me as an old surgeon, I think about ways of how a robot can do something that I am doing. That might just not be the right way of approach, because as I realized when we had these children in our laboratory, these children are actually growing up with smartwatches. I still don't have a smartwatch. With smartwatches, with the knowledge about robots and how to use robots and how to integrate robots into their normal everyday life experience. And the program is basically called RoboNatives. And what I think will lead robotics forward is not just the technological growth, but rather the grow with technology. So it's not that we define what the next generation of robots will be, but these young people will define how they can use robots for specific tasks very naturally, very much the same way as we currently use cell phones. One very important aspect still needs to be, it's always at the end that's the problem, but it is central to everything, and I think I alluded to it quite extensively already, is we need to bear in mind what the ethical principles are under which we work. And obviously the first two are already proposed with Hippocrates, which is do good and to try not to harm. That needs to be transferred into robotics also. However, quality of life needs to be defined. How should a robot know what quality of life is? We also have different conceptions of quality of life. And that also refers to the ethical relativism. That means we in Europe, all of us, all of the listeners, and most of the people in the European Association of Neurological Surgeons have a certain concept about ethics, be it moral philosophy as with Kant, or be it utilitarianism as with Mill. However, it's almost alike, and there are differences that we can talk about. However, ethics is not ethics all over the world. And we need to make sure that those people that actually program those robots are given the opportunity to find out in which direction they should work. And justice, of course, equal opportunity, truthfulness, and honesty. Now, ethics for robots is, and it's an old thing, it's by Asimov, and it's still very good. It says a robot may not injure a human being, a robot must obey, and a robot must protect. Now, that all is very easy if you have an ethical ground truth that all these laws are on top. And this needs to be borne in mind, and this needs to be advocated by us in regards to the engineers that are excited with what they can produce and how good their robot is, how great it performs. And we need to make sure that these issues are also not forgotten. And we are not the only ones thinking about this. And Nikolai, I think when Greg held his talk in our first session in Belgrade last year, he said that he was the only neurosurgeon in a group of around 300 people, make it 256, who were talking about ethics in surgery. And we need to be part of that. The association that you represent with your task force needs to be part of that, because the AI people already think about how to do embedded ethics for technology. And they think about ethical issues. Now, whichever way those are being defined, they obviously have a lot of philosophers there, but it needs to be practically put into place during surgery also. And they need to, and they already say they want to discuss with clinical field of deployment. We need to define what we actually want and how this can be implemented. And however, they end with something which is very good. They want an interdisciplinary group to work on these issues. Now, we need to be part of this interdisciplinary group in order to make sure that our voices and through our voices, our patients' well-being is being represented. I didn't go into neuromodulation, neuroregeneration, and neuroenhancement. Those are basically topics for neuroethics. What we need to, if we are working with, naturally we need to work on these also. But for the time being, for this talk, it's the ethics for robots. How do we use robots ethically, and roboethics, meaning how can we actually have ethics within a robot as empathic ethics in order to make sure that we can work not a robot but with robots. So in conclusion, I think for the first part at present we best define robots or robotic or surgical robots by the manner how they interact with us by the degrees of freedom as Young has proposed. Presently, most of them are master-slave. Whether we can find cooperative or collaborative, which would be point 4 and 5, is I'm very skeptical about that. However, I think that those robots need to have some local autonomy. However, I doubt, and I'm very skeptical about general autonomy. I wouldn't, as I say, I wouldn't want to have a robot work on me. The demands that we have are specific to the specialty. You saw that in the initial area. And what we need to find and what we need to bear in mind is, as I said, robots are basically, it's a Czech origin, and it basically refers to servant. And we decide whether we want a stupid or a smart robot. And we need to define how this area is being interrogated and being worked on, and we should not and never may leave a firm ethical ground basis. Thank you for your attention.
Thank you very much, Araya. It was a very interesting, intriguing, I would say, presentation from your part, and of course, very interesting topics. Topics that we have to work on to obtain the right answers. This will be a long way to go. What I think we could agree easily is that all that you have spoken about in this presentation will change the way we work and probably our society as a whole. So it will be better for us to be prepared for that. And by discussion like this one, by webinars like this one, I think that we can make our small steps in this direction and to be better prepared at the end. So now it's time for questions and answers. I will use the privilege of being a moderator of a moderator, and I will start with my first question. I suppose that you have heard that Elon Musk said that AI will not only take away our jobs, but also will take the meaning of life. What do you think about, I'm quoting it correctly, what do you think about this, do you think that really robots can take the meaning, and AI, the meaning of our lives?
No, I don't. Obviously I don't. After all of that, I'm not even for autonomous surgical robots. But I don't think that. Let me put it this way: in order for AI or any kind of non-human intelligence to actually know what life is, there needs to be more than just informational input, and there needs to be some. Let's put it short circuit that goes. If you look at science fiction, if you look at the movie I, Robot, it's those snippets of code that are meaningless that eventually evolve into something that might come close to anything that is human. So I'm not sure about. I'm sure that AI will not be able to comprehend the meaning of life. but I am not sure whether the development of AI might not, by pure chance, very much like our genetics, that by pure chance led us to become humans, eventually evolve into something more interesting than we can fathom.
Okay, thank you. Thank you. I see a question here. Master slave is probably not the best descriptor of any system in the 21st century. Yes, probably we have to think about another notion about this type of systems. But the question is,
It was, yeah, go ahead.
what can robotics do that the human surgeon cannot?
Well, it depends on what you really want. You need to dissect the surgical act into various portions. A human can be more intuitive. You can have a hunch. You can rely on your experience. A robot can perform a set task, a clearly defined task, be it drilling of the temporal bone with leaving the facial canal only to the 10th of a millimeter with bony coverings. Those things a robot can do very precisely. However, you need to tell the robot how precise precision really is. I had another slide for one of the previous iterations of this talk, where Google Maps in the original told me very precisely that in order to go from Le Havre to Boston, I need to swim for 5,760 kilometers. That was very precise, but utterly useless.
Thank you. Thank you very much for this nice example. Marcel, I see that Marcel has a question.
Yes, a short question, actually. Arya, first of all, thank you very much for this fantastic presentation. And I honestly think we live very fascinating times when things are so rapidly evolving. Yeah, I mean, a decade ago, we could not even dream about having some kind of so much interaction with the robots in our activities. But this is growing. But still, we live in very early stages of robotics. So at least in neurosurgery, I mean, when we discussed about robots generally, we have some expectations. So we have the expectation that the robot will do something for us while we are doing something else or resting. So we have it routinely in our kind of social life. So the robot can cook a pizza, they can mow the lawn, they can clean the room, they can do lots of things for us. But in neurosurgery, at this stage, this is very early. So the only thing which robot is doing, at least in spine surgery, for example, is just bringing an instrument in some specific trajectory and holding this while we're inserting the screw. So the robot doesn't drill, it doesn't decompress, it doesn't remove the tumor, it doesn't bend the rod yet. So it is just early stages. Now, I trust things will rapidly evolve. I think there is some work that the robot may do some more active input for us. And the question is more ethical question, is if robot makes a mistake, for example, by mistake, the robot will insert the screw into the spinal cord. For God's sake, hope it never happens. But if this happens, who should take responsibility for this? Is it a surgeon who is supervising this? Is it a company who did not assure safety? Is it the hospital who did not check this? This is one of the questions we really need to address. And I just want to ask you and maybe other colleagues, what is your opinion for this kind of scenario? Because it potentially may happen. It is a very real scenario.
Well, harm being done by a surgical robot, usually the companies that sell robots are very good on the legal stuff. So this is a medico-legal question. So a classic is garbage in, garbage out. So if you program the robot incorrectly, or if you give him the wrong entry and target point, as you alluded to, then obviously the surgeon is responsible. The surgeon is responsible very much the same way in misusing a navigational system. I mean, if I read in reports that the navigational system was wrong and therefore the carotid artery was severed, I just say, well, a bad surgeon is not getting a good surgeon by using a navigational system, and it's very much the same thing. A robot doesn't make a bad surgeon into a good surgeon. So that is the major issue. And at the end of the day, I always, and I think I'm absolutely sure we agree, at the end of the day, the robot is not going to talk to the relatives. We are talking to the relatives. So it is our final decision. And therefore, no, I would never trust a robot in that perspective. Let's not say never. Let's not say never. I can be convinced, however, not at present.
Thank you. I saw that Alessandro rose his hand, but I think that Marcel.
Yeah, I had the same question. Thank you very much, Professor Nabavi. It was a really interesting presentation. My question was specifically about liability, but you already answered it, so thank you very much.
Well, if there's a lot of liability liability talk, in particular to the Da Vinci. I mean, what if one of the tendons breaks? What if one of the grasping forceps, breaks within the abdominal cavity, and you need to do real surgery to take it out? I mean, all those issues are related to wear and tear, and if the instruments are correctly controlled, the company is never going to take any kind of liability for that. They have, as I say, they have very good lawyers at that stage. But we should rather be concerned with the human factor, meaning if a human misuses a robot, where that also is clear liability. If you use a robot, the robot does correctly what it's supposed to do, but in the incorrect position, obviously the surgeon is going to be liable to that.
Do you think the consent form for patient should change in any way?
Excuse me, sorry, again?
Do you think the consent form for patients, the formative consent for the surgery, would change in any way?
Eventually you will need to, I mean, different from now, we don't enumerate all the instruments that we use. We don't enumerate navigation system and microscope. However, if you use a robot or if you use anything that can do significant harm, then that needs to be included in the consent form, and this definitely has to be said. Now, the problem goes even further, if I may add to that, is not just that when we use a robot, but more and more patients are informed, or they think they are informed about the usages of robots. They think that robots are much better than surgeons because they're more precise, but I already alluded to my concept of precision in regards to my example. And then they come and they demand to be operated by robots. Now, this doesn't happen in neurosurgery, but for instance, with hip displacement, there was a huge surge about the RoboDoc. A lot of patients wanted to do that, and a lot of systems were sold, and a lot of people did not use them correctly, and there's a huge wave of liability suits following, or has been following for the last 15 years.
Thank you.
Thank you. I see that we have a question from Akanksha Agarwal. Thank you, Professor, for this insightful presentation. I was wondering if you could tell us about what role do you think AI can play in predictive modeling for neurosurgical risk and complications?
Well, that is, there will be a role for it. What role, I cannot predict, but I'm certain that what we need to put together, there was a project from Heidelberg couple of years back, which was called cognition-guided surgery. They were trying to define how to put surgical experiences, surgical videos, surgical results, and surgical documentation into a computed system in order to produce predictions about future surgery and about next steps within a specific surgery. And now that didn't really work out that well, but that was 10 years ago, and I'm sure that let me just put it this way, the WhatsApp messages that I sent you were mostly by the speech recognition that my cell phone had. So who knows what will happen in the next couple of years? And I think AI will have a large influence. And again, I think that we need to be on top of that. We need to make sure that the way goes in the right direction. I can't hear you.
Yeah, I have a question, Nicola, if you might. Hi, thank you very much for your presentation. It's on the side of how you show the approach to designing this new robot. I have the impression that designers are trying to mimic the human surgeon instead of building a perhaps more performant machine for the task. For example, you brought the example of a vacuum robot. It is nothing alike, for example, myself when I vacuum my home. It doesn't need a head, a hand, nothing like that. So what are your thoughts about that?
I absolutely agree, and this is why I give lectures in the engineering, electrical and mechanical engineering department of our university, and then invite the students to come into the OR, because what the discussion, the way it works at present, as you already alluded to, and as I said also, when the usual way a discussion works is the mechanical engineer comes to you and you say, can't you build me a machine that does this and this? And then you show them a video of your surgery. And then obviously the only way the mechanical engineer thinks about the situation is to mimic exactly what he saw. And so the basic issue, and this is what I alluded to with common ground, the basic issue is to move beyond the techniques towards the problem. And that is also a task for us, because we need to actually understand how mechanical engineers think, or at least try to understand, make them try understand how we think, and not use every single word to make it by the book, but to solve a problem. So I absolutely agree, particularly because robots they don't have to be humanoids, they can be tiny, they have different degrees of freedom, they can reach into spaces that we cannot reach at all. And so the problem will need to be defined. And that's why I was so glad when I went to our research lab and saw all those young children with RoboNatives in the RoboNatives initiative, because that is exactly going to loosen the block that we have in our brains. Because when I think of a robot, I think of something that does the same things that I do, only better and without being tired. That is an anachronistic way of thinking about it. We need to look forward. We need to be problem-oriented and see whether we can work around the corner. I did not show any results or any research on continuum robots that work around the corner, the non-linear trajectories, for instance. Those are very, very interesting future topics.
You are mute, Nicola, you're mute.
Sorry. Thank you very much for this this interesting conversation and discussion at the presentation. I'm sure that in the near future we will have another webinar related mainly on ethics, because I'm not sure that we are really prepared on this topic. The fact that we had a very important mistake in the software a few weeks ago that made a real mess on the airports and even in some hospitals means that we are not ready for this. And of course, who is responsible for that? Are we ready psychologically to bear situations like this? I think that these are very important questions, especially regarding a very concrete situation between a physician and a patient. So I think that there are very interesting webinars that are yet to come. Thank you, Araya, for this outstanding presentation and for the open topics, because as I said, I'm sure that we shall come back to this again and again. Thanks to all of you for being there tonight. I think that we're going to meet each other in Sofia in October. You are more than welcome for the European Congress of Neurosurgery. I'm sure that There will be very interesting discussions in the format of ETIN, of the task force of ETIN, and I will be really glad to meet you there. So see you very, very soon.
Thank you very much.
Okay, have a nice evening until October in Sofia. Bye-bye.
Bye-bye.